Some brief thoughts today about perfectionism in the big picture, as often the case here, contextualizing game development, but probably applicable in lots of other things. There's been a couple cases that came up recently where people were working within home team on different projects, and in one case, somebody's working on an approach to some shaders to put a toon kind of outline on some different meshes in the environment to show interaction. In another case, somebody's looking at going through some of our introductory learning material, and they're trying to figure out how to make the collision work better for the ball in a breakout style game. And in both cases, they were running into a situation where when we zoom out, it's really helpful to look at the specifics of the case instead of getting lost in the weeds on perfectionism. And so, like, for the context for these, like, literally, in one case, he was working on a much more complicated mesh, and he was like, well, it doesn't look good on this very complicated mesh. And the more we talked about it, the more we realized that that kind of object in the scene was never going to need this shader. So instead, we pivoted our attention towards, let's look at what are the actual objects that will need this shader, and is it suiting our needs there, rather than trying to solve a general all-purpose scenario. In the other case, it was somebody who, again, was looking at physics of, for those of you who've been through my courses, Code Your First Game, or the attached course, How to Program Games, Part 2 that comes with the textbook. There's looking at kind of this breakout style course, which, of course, in a high level is really there to teach you how to go from a coordinate XY position into a tile lookup for faster grid-based collisions. But he's looking at, okay, ball thickness and paddle thickness and brick thickness. And this is a common question that came up in a lot of questions over the years on Udemy, for that matter. And the problem is that game physics, if you start to drill in deep, is an incredibly deep rabbit hole. And one of the things that I love about game development, and it's also one of the challenges of game development, is this is true for nearly anything, about rendering pipeline, about art choices, about color choices, about so many different things you could spend your life iterating into detail and becoming a master in. And so for physics, for example, there's some slides here I'll kind of show somewhere over this picture of an Aaron Cato presentation from, I think, 2014 GDC. And he's given a bunch of talks over the years. Aaron is the developer of Box2D. It's a physics library, which means a more general solver. And what happens when we start trying to drill in on game physics is we start to recognize that, okay, well, we begin from the simple stuff of, well, it should seem thicker. And then, well, sometimes what if I want a thinner obstacle for it to collide with? And what if I want the object to be able to go faster? And then what if I want to be able to apply torque when a car hits a wall, or if multiple objects collide with each other? And we start running into is that something that was relatively simple to approximate, to handle good enough for a specific retro use case, very quickly blows up rapidly into involving calculus for variable time step, into increasingly advanced layers of physics math. And unless you commit to being, that is my area of specialization as an engineer, I'm going to be a physics engine programmer, then you can completely get lost in the weeds and lose your perspective on the choices you're making about the development of the overall project, about the effect to the player. And one of the things I love about game development is a context to learn in for usable intelligence, again, is kind of a recurring theme, is how much it makes us look at each one of these areas where I could very much go in deep and try to become a specialist in, like I say, rendering optimizations, or more likely, I want to learn just enough to be able to practically unblock myself, to be able to move forward, to be able to fit the various pieces together. You may still find that there's areas you choose to enjoy digging a little deeper into, that you have a curiosity there, that it's enjoyable to do, or just to show yourself that complexity, to kind of make those mistakes firsthand, to kind of learn from where the line is before your comfort level cuts off. But that's typically why when we're working on games, even though when I got started in 1997, I was using code from the back of books to directly write video address pixel colors to the screen to make rectangles and pixels colorful. And I was looking up routines to write code to draw circles, which it turns out there were literally kind of PhD thesis research work done on how to draw circles faster in old graphics cards. And that rather than wanting to get lost in the weeds of reinventing that, of how to draw a circle, at some point I accepted using what at the time was called the Allegro library. These days we turn to solutions built into JavaScript on Canvas, we turn to solutions like Unity and so on to handle a lot of our Java routines, because somebody has done a ton of work to figure that out. And at some stage, we want to think about where and why and how to draw that circle, how big to make the circle, when to make the circle vanish, not how to get the machine to do it at all. Any more than we could also get lost in the weeds about how your monitor displays, how electricity is delivered to your house, any of these other layers where we have to build on a certain layer of comfort of, I'm grateful someone else solved this part for me. And that abstraction ladder, of course, is variable in terms of depending on the level of tech people like to build on, what parts of the problem they want to focus on. We see the same thing happen even in Home Team within a fixed series of platforms, which of course in Home Team we work with either Unity C# or JavaScript on browser canvas for HTML5, or more recently Godot this year. Even within those, there's this big distinction of sometimes we're meeting with a project lead for them to start a team project. they'll ask how far along the prototype needs to be before they pitch and welcome others onto it. And what happens is, it depends on what parts of the project they want to focus on with the team. If they basically have the core mechanics already working for a puzzle game, for an adventure game, for one of those kind of things, then instead, the whole production pipeline with the team becomes focused on what story are we telling, what puzzles are we designing, how are we creating our encounter ambushes, what enemies do we have here, rather than how to get them to do those things at all. You can do the opposite, where instead of starting from that prototype that's fully playable core mechanics as a foundation, instead you look at, hey, the point of this team project is going to be, by the time we hit the finish line, I can do the things. I can double jump. I can get these power-ups. I can walk through walls. I can, load and change levels and stuff. And in those kind of projects, typically by the time it releases, at least within our kind of 6-month scope of people mostly part-time on stuff, they're not going to reach that same level of polish, but it's a different kind of focus. And it, again, depends upon how much we're building on. Is there already a solution here for how to animate, for how to do basic collision handling, for how we're treating input, which is often still another layer on top of whatever system we're building in, right? Even if you're using something like Unity, or even if browser has built in some advantages, some hooks for the browser, you're still typically building in at least one layer of abstraction on top of that for how your game is going to handle that as remappable input keys for certain functions that connect to certain functionality features in the world. But it depends on what we're building on. And it allows us, I find that same sort of thinking about this flexibility of, okay, within this context, I need enough to get the effect I'm going for, and then I got other things to focus on, this big picture to get this project done. I just find it both a very helpful way to think about projects we encounter, obviously, again, outside of games as well. The same things come up all the time in workplaces, in our professional lives, where there's only so much budget, time, energy to be able to allocate to certain things before the end of the quarter or the end of the year, and then making conscious choices about, okay, well, proportionally, this is the amount or level of attention that this deserves in comparison to other parts. It's the same thing that also enables us to work with teammates, because it means that we no longer feel the need to understand that entire stack from top to bottom of how every single bit and piece works. This is something that's a common challenge for people who are shifting from solo game development into team game development, and a part of what I've helped a lot of people with over the years is that it can seem somehow more daunting to do it all yourself, but really what you get there is the comfort of you understand every single bit and piece of how the animation code works, how the collision works, how the world loads, how the format saves, and so on, versus once you're in a team context and you're having to build on a certain layer of abstraction that other people know the underpinnings of, a lot of the work becomes trying to find a way within a bigger code base to navigate without having to find out all the details of how the collision here is handling, without having to find all the details about how the world map is loaded. What can I build with it? What can I do with it? Or if I'm changing or fixing something about it, how little about it do I have to understand to be able to go in there, make that change, pull back out, repeat? And that becomes sort of a different type of skill that, again, is really the same sort of skill we bring into if you're jumping from more retro game programming, like we start people on, up into something like Unity, where suddenly, instead of having a chance to kind of have to look up the math and do it yourself, there might be a built-in function. We see the same thing actually recently in Godot, where a project lead was running into a question about trying to get a defender in a kind of dodgeball soccer style game to intercept a ball. And I started talking about the math to do it, which is what we would do typically in our JavaScript projects, where we keep it vanilla. We don't use outside frameworks for JavaScript games. But in the case of Godot, there was literally a built-in function that gave him the answer he needed, which allowed him to, again, not think about how to do that, but the next layer of abstraction up of when, why, or how to incorporate that into his character behaviors and so on. But anyway, one of the things I love about game development is that each one of these areas of involvement that we're working on our projects is a very deep area of inquiry. You could master, you could practice, you could spend your lifetime becoming a world expert in. Or we kind of get a sense for, okay, well, I can respect the depth of that, but there's so many other bits and pieces to attend to, and so I'm going to find a way to solve this use case here, and then move on to the others. One of my very first mentors, I'll end with this, one of my very first mentors in a workplace was John Salwitz, guy who'd worked on Paperboy many years ago for the arcade, and something he pointed out was that a lot of mistakes he saw a lot of developers doing was that they would try to overly generalize everything, right? They would try to each time solve a problem as if it had to solve every single conceivable, imaginable scenario. And while it's not a bad thing to ask yourself those questions, you can get a lot more done with the same time, the same budget, the same energy, if instead you're very conscious and deliberate about, this is what we're building. Here's the constraints we can take for granted, right? It's the same reason why Doom was able to run on a 386 pre-3D graphics processors, because they accepted some certain things. No land would be over other land. You couldn't rotate. You couldn't jump. There were certain things they drew as constraints, which made the whole thing possible. And especially in the modern context, where there are great tools out there like Unity or Unreal or Godot, And there are great frameworks like Box2D by Aaron Cotto for physics, or graphic solutions, or other kind of frameworks that we use for various kinds of input and so on. It's a case where you can say, okay, well, unless I'm trying to remake Unity, unless I'm trying to compete in the space of engines like Godot, then maybe I'll let them do the most general case stuff as best they can. And in my situation, I'm going to focus on one project at a time. What are my real use cases here? And then finally, that leaves us with a clear pattern of, if there are some reusable elements, we have a really practical, immediate, grounded sense because we've done it. We've seen, here's the pieces I keep reusing, and helps us build our own kind of layer of reusable abstraction above it. Anyway, that's it for the day. I just want to discuss here again perfectionism balanced with the bigger picture. It's a lifelong skill that I think game development's a great thing for conditioning us in, exploring, playing with those boundaries in a safe, recoverable way. And it's just so, one of the things obviously I love about game development is that there's kind of a no BS zone of either it works or it doesn't, it exists or it doesn't, the game's released or it's not. Can't fool yourself about if you're not spending your energy in the right ways that you intended to. That's it for now. Catch you another day. Thanks for being here. Bye for now.